Friends, this is a model of a Francis turbine. It consists of a casing. This is the inlet part. So this is the inlet port from where the water enters. This black color thing, that is your guide vanes, and inside that is your runner, and water comes out from this outlet portion where the shaft is connected. Okay, so when the water enters from this part, here what happens, this guide vanes guides the water and it flows inside the runner. So this runner, which in turn is moved by the water, and it is once again flowed to the outside outlet part of the shaft. So here the water enters from this part, it is guided by the guide vanes and it enters the runner. So when it enters the runner start moving, and from this part the water comes from to the outlet. So this is the model of a Francis turbine, and this is how the water comes inside and moves outward. Thank you. Good morning students. Today we are going to learn velocity triangle of a Francis turbine. So what is a Francis turbine? Francis turbine is nothing but a reaction inward flow reaction turbine. So what is a reaction turbine? Reaction turbine is a turbine which possesses your kinetic energy as well as pressure energy. Next, what is inward flow turbine? Inward flow radial turbine is nothing but a turbine in which water flows from outward to inward in radial direction. So here we are going to learn the velocity triangle of a Francis turbine. So this one is the triangle, a velocity triangle at inlet, and this one is the velocity triangle at outlet. This is the vane. So what is V1? V1 is the velocity at inlet which is making an angle alpha. So what is alpha? Alpha is the angle between the direction of motion of the plate known as guide blade angle. Next, relative velocity, VR1 is the relative velocity which is making an angle theta. So what is theta? Angle made by the relative velocity with the direction of motion at inlet. Next, V1 is making two components, that is one vertical component and other one as horizontal component. So this one VF1 is the vertical component, VW1 is the horizontal component. VF1 is also known as velocity of flow at inlet. VW1 is also known as real velocity at inlet. Next, U1 is the velocity U1. U1 is the velocity of plate at inlet or known as tangential velocity. Next, further we are going to learn the outlet triangle. So here in this triangle the beta angle is 90 degree. So here if this beta angle is 90 degree, then what happens? V2 is equal to F2. So now what is V2? V2 is nothing but the velocity of jet of vane at outlet. Next, what is U2? Same, tangential velocity of the vane at outlet. Next, VR2, this is the relative velocity at outlet. So VR2 here, this is the VR2, and V2, since angle beta equal to 90 degree, so V2 equal to F2, and VW2, this VW2 equal to 0. So this becomes U2. So here similarly, as we have seen in the inlet triangle, VW2 is the real velocity at outlet, VF2 is the velocity of flow at outlet. So this completes the velocity triangle of a Francis turbine. Thank you.